Research shows path toward protocells on Saturn's moon Titan. NASA research has shown that cell-like compartments called vesicles could form naturally in the lakes of Saturn's moon Titan. Titan is the only world apart from Earth that is known to have liquid on its surface. However, Titan's lakes and seas are not filled with water. Instead, they contain liquid hydrocarbons like ethane and methane. On Earth, liquid water is thought to have been essential for the origin of life as we know it. Many astrobiologists have wondered whether Titan's liquids could also provide an environment for the formation of the molecules required for life, either as we know it or perhaps as we don't know it to take hold there. New NASA research, published in the International Journal of Astrobiology, outlines a process by which stable vesicles might form on Titan. Based on our current knowledge of the Moon's atmosphere and chemistry, the formation of such compartments is an important step in making the precursors of living cells. The process involves molecules called amphiphiles, which can self-organize into vesicles under the right conditions. On Earth, these polar molecules have two parts, a hydrophobic end and a hydrophilic end. When they are in water, groups of these molecules can bunch together and form ball-like spheres like soap bubbles, where the hydrophilic part of the molecule faces outward to interact with the water, thereby protecting the hydrophobic part on the inside of the sphere. Under the right conditions, two layers can form, creating a cell-like ball with a bilayer membrane that encapsulates a pocket of water on the inside. When considering vesicle formation on Titan, however, the researchers had to take into account an environment vastly different from the early Earth. Titan is Saturn's largest moon and the second largest in our solar system. Titan is also the only moon in our solar system with a substantial atmosphere. The hazy, golden atmosphere of Titan kept the moon shrouded in mystery for much of human history. However, when NASA's Cassini spacecraft arrived at Saturn in 2004, our views of Titan changed forever. Thanks to Cassini, we now know Titan has a complex meteorological cycle that actively influences the surface today. Most of Titan's atmosphere is nitrogen, but there is also a significant amount of methane. This methane forms clouds and rain, which falls to the surface to cause erosion and river channels, filling up the lakes and seas. This liquid then evaporates in sunlight to form clouds once again. This atmospheric activity also allows for complex chemistry to happen. Energy from the sun breaks apart molecules like methane, and the pieces then reform into complex organic molecules. Many astrobiologists believe that this chemistry could teach us how the molecules necessary for the origin of life formed and evolved on the early Earth. The new study considered how vesicles might form in the freezing conditions of Titan's hydrocarbon lakes and seas by focusing on sea spray droplets, thrown upwards by splashing raindrops. On Titan, both spray droplets and the sea surface could be coated in layers of amphiphiles. If a droplet then lands on the surface of a pond, the two layers of amphiphiles meet to form a double-layered vesicle, enclosing the original droplet. Over time, many of these vesicles would be dispersed throughout the pond, and would interact and compete in an evolutionary process that could lead to primitive protocells. Discover the latest in science tech, space with over 100,000 subscribers, who rely on phys.org for daily insights. Sign up for our free newsletter and get updates on breakthroughs, innovations, and research that matter daily or weekly. Email if the proposed pathway is happening. It would increase our understanding of the conditions in which life might be able to form. The existence of any vesicles on Titan would demonstrate an increase in order and complexity, which are conditions necessary for the origin of life, explains Connor Nixon of NASA's Goddard Space Flight Center in Greenbelt, Maryland. We're re-excited about these new ideas because they can open up new directions in Titan research. It may change how we search for life on Titan in the future. NASA's first mission to Titan is the upcoming Dragonfly rotorcraft, which will explore the surface of the Saturnian moon. While Titan's lakes and seas are not a destination for Dragonfly, the mission will fly from location to study the moon's surface composition, make atmospheric and geophysical measurements, and characterize the habitability of Titan's environment. 8. More information. Christian Meyer, ETAIL. A proposed mechanism for the formation of protocell-like structures on Titan, International Journal of Astrobiology. doi 10.1017S14735504251-00037. Journal information. International Journal of Astronomy.